And in this video, we're going to use trigonometry to find an indicated angle. So we've been presented with a triangle. It is a right triangle, and it has side lengths 5, 12, and 13, and we've been asked to find the indicated angle. Looks like we're going to have to use trigonometry to find this angle theta. So our first step is going to be to label the triangle, and we'll label it from theta's perspective. So from theta across the triangle is the opposite side. So this is the opposite. The longest side of the triangle, the one opposite to the right angle, is the hypotenuse. And the remaining side, the one that's also touching the angle theta, just right beside it, is referred to as the adjacent. So we've got this triangle labeled. Next, we pick our ratio. Now, in this case, we're going to use SOHCAHTOA to help us to decide which ratio to use. And actually, because we have information about all three sides, we can pick any ratio we like, because remember, your sides are just your opposite and hypotenuse, adjacent and hypotenuse, or opposite and adjacent, and we know all of them. We're going to use sine for this one just because of the fact that I was making videos involving the sine ratio. So we're going to pick sine, which means I'm going to write the sine, and I'll leave room to put my indicated angle, is equal to, and I'll create a ratio of my opposite over my hypotenuse. So my indicated angle here is theta. I don't know it, it's a variable, and I'm going to put it inside the sine function. And I'll put the opposite over the hypotenuse. So the opposite is 12, and the hypotenuse is 13. Now, this is the type of problem we have to use our calculator backwards for. But first, we have to evaluate what 12 divided by 13 is. So I won't do anything with the left-hand side yet. I'll leave it as just sine of theta. And remember, this line was just a blank, leaving us a blank so that way we had a place to put an indicated angle. So I'm going to evaluate 12 divided by 13. I suspect it's going to be fairly close to 1. It is. And I'm going to keep it to 4 decimal places. So this will be 0.9231. So 12 over 13 was 0.9231. Now, when you have a problem like this and you're looking to go from a missing angle from a ratio, you have to use the sine operation backwards. On your calculator, it looks like the second function. So you can see I have sine and sine inverse. So I'm going to use second function sine inverse, and I'll know on my calculator I've done it right because I'll see this exponent of -1, and I'll type in my values. So 0.9231 because I rounded to the 4th decimal place. And I go ahead and hit equals, and it gives me an angle of 67.38, or we can just say 67.4. And that is the angle of theta, 67.4 degrees. Now, if you recall that all triangles have 180 degrees total, there's a very easy way to find this missing angle as well. But I'll leave that for another video when we talk about solving triangles. So that's how you use a trigonometry ratio to figure out an indicated angle, knowing the related sides.